This is solving quadratic equations with the quadratic formula. So we want to be able to answer what is the quadratic formula, so you should be able to memorize that, and when and how would you use it. So we'll go over how the quadratic formula is derived, like where it comes from in class, but for now, just want you to make sure you have it written down and you're going to need to memorize it. So it's x equals negative b plus or minus the square root of b squared minus 4 times a times c, and the whole thing is over 2 times a. So make sure you have this written down and make sure you start memorizing it if you don't remember it already. And then the discriminant tells us how many and what type of roots the function is going to have. And the discriminant is what's underneath the square root. So has nothing to do with the square root. It's only b squared minus 4 times a times c. So once we find this discriminant number, it's going to be able to tell us about the roots. And so we're going to fill out this chart. You're going to have to be able to fill out a blank one, so make sure you get this all down. But the discriminant is going to tell us, depending on the value, the number of it, the number of roots, the type of roots, and should be able to do an example of a graph from that. So once you find out what b squared minus 4ac is, that'll give you a number. If that number is positive, so greater than 0, and it's a perfect square, so for example, like 25, that's a perfect square positive number, then that means you're going to have two roots. They're going to be real and rational. So that means on a graph, they would cross nicely. You should be able to find them at nice, real, rational numbers. If your discriminant, the number is positive, but it's not a perfect square, so something like 71. Okay, 71 is a positive number, but you can't take the square root of it. It's not a perfect square. Well, that means you still have two roots, and they're still real, but now they're irrational. So we can still see them cross on a graph. It's just they're going to cross at irrational numbers. So not nice, pretty numbers like the rational ones. Now, the third value you could end up getting is if your discriminant is equal to 0. Okay, so if you plug in b, a, and c, and you do the discriminant formula, and you get 0, that means you only have one root. It's real and rational. And we've talked about this before. It means your quadratic's vertex is on the x-axis. That one's not exactly there, but like that. So you only have one root, so the vertex is on the x-axis. Now the last type is if you do b squared minus 4ac and you get a negative number. So something less than 0. Then you have two roots, but this time they're imaginary. So that means your quadratic doesn't cross. So you won't see any real roots because it doesn't cross the x-axis. You have imaginary roots. So let's do an example. So here's x squared plus 16 equals 0. Okay, it has to be in standard form in order for you to solve using the quadratic formula, which this one is. And so we know my a is 1 from standard form. I don't have a b, so my b is 0. And then my c is 16. So that's the first thing I would do. Make sure it's in standard form. Make sure I identified my a, b, and c. And then start plugging it into the formula. And remember that formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to look for my discriminant first, b squared minus 4ac. So b squared, that's 0 squared minus 4 times a times c. So that's 0 minus 64. So my discriminant is negative 64. So remember, if it's a negative discriminant, that means I'm going to have imaginary roots. So that can kind of give us an idea of what our answer should be. We should have an I in our answer. Okay, so now I'm going to go back and make sure I plug everything into my quadratic formula. So negative b, which is negative 0, plus or minus the square root, and I already found my discriminant over here. so negative 64, over 2 times my a, which is 1, so it's just 2. Okay, so from here you just simplify. So negative 0, I mean that's just 0. You don't even really need that anymore. Plus or minus the square root of negative 64 over 2. Now the square root of negative 64 is 8i. So I have plus or minus 8i divided by 2. And that is plus or minus 4i. So x equals plus or minus 4i. So that goes with the discriminant theory that I have two imaginary roots, which I do, plus or minus 4i. So this graph would not cross the x-axis. Okay, so one more example. Make sure it's in standard form, which it is. And then I identify my a, which is 9, my b, which is 6, and my c, which is negative 8. And I'm going to plug that into my quadratic formula. X equals, and then remember I'm going to find my discriminant first, just so I can know what type of roots I'm going to have. So b squared minus 4ac is my discriminant, just what's underneath the square root, and that gives me 6 squared minus 4 times 9 times negative 8. And when you do the math on that, you end up with 324, because that is 36 plus 288. And that gives me 324. So my discriminant of 324 is a positive number, and it's actually a perfect square. It's because 18 squared is 324. So that means I should get 2 real rational roots based on that chart we filled out. Okay, because it's positive and a perfect square. So now I'm going to go back and find my roots by plugging them into here. So I have x equals negative b, so negative 6, plus or minus the square root of 324 over 2 times my a, which is 9. So negative 6 plus or minus 18, because the square root of 324 is 18, over 18. And I'm going to go ahead and split it up from here. So I've got negative 6 plus 18 over 18, and I have negative 6 minus 18 over 18. So you've got two different numbers over here. So you're going to split up the plus and minus. So over here, negative 6 plus 18 over 18. So negative 6 plus 18 is 12 over 18. And then I can simplify that into 2/3. So there's one of my roots. And over here, negative 6 minus 18 is negative 24. And over negative 18. And that will simplify into negative 4. Sorry, this is a positive 18. I don't know why I wrote a negative. So negative 4 over 3. So I do have 2 real roots. There are no i's in here. And they're also rational because they're either repeating decimals or terminating decimals. Well, actually, both of these are repeating decimals. So I found my discriminant to tell me what kind of roots. Then I went and plugged it all in, did the math, split up the plus or minus sign, and simplified my fractions to get my 2 roots. So this graph will cross, and you'll be able to see it at 2/3 and negative 4/3. So this is one root, this is the other root. Don't forget to rewatch it as many times as you need to make sure you understand. Make sure you have that chart. You'll have to fill out a blank one, and then questions and summary. That's it.